Hi, I'm Mark, software mentor from Team 93. Welcome to our second video in our series on how to use WPILib to write robot code in Java. In this particular video, we're going to take a little bit of a deeper dive into the robot class, which we briefly touched on in our previous video. So as I mentioned in the previous video, the robot class is the main entry point of your program. And actually, if you look at the main class, that becomes pretty apparent. The main method of your Java program, all it's doing is calling the robot base start robot. And the robot base is what your robot class ultimately inherits from if you look at the inheritance hierarchy. So the place where your program starts is essentially the robot class. You don't need to worry too much about robot base or the main program. And in fact, in previous years, before we were using VS Code, the main.java program typically didn't even appear in WPILib projects. So as I mentioned, the robot class is your main entry point, and it inherits from timed robot. I mentioned in the previous video, the fact that it inherits from timed robot is a sign that we're using a command-based robot, because a timed robot is what you would inherit from in that case, and that's the kind of robot that we're going to be talking about for all of these videos. So in terms of what the robot class is generally used for, the first thing that you'll notice in most robot classes that you look at, if you're looking at example code or other teams' code, is that the robot class will contain pointers to most of the subsystems. And it'll also contain references to the OI and also any commands that aren't tied to any particular button. A great example of that would be the autonomous command. It's not tied to any particular button because autonomous mode isn't a teleoperated mode. So that kind of thing is usually instantiated within the robot class. You might also see, as you see here, things related to shuffleboard or smart dashboard for logging various things to shuffleboard or accepting user input, like for instance, choosing a particular autonomous mode. Classes related to that will generally be found within the robot class. And going through the different methods here that you'll see within the robot class, the first one that we see here is the robot init. And this is a very important function. Generally, this is where most of the subsystem and OI and robot map initialization takes place. You might be wondering, if you're familiar with Java programming, why we do this initialization within a robot init method instead of doing it in the robot constructor. The main reason for this is because of the guarantee that robot init gives us. And that guarantee is that when robot init is called by the WPILib program, we know that the rest of the WPILib has been initialized at this point before the robot init is called. So things are generally in a safe state to start creating subsystems and the OI and the commands that are created within that class and so on. So generally, it's safest to do most of your initialization, most of your object graph construction related to subsystems and OI and so on within your robot init. Or if you're doing like creation of commands within your OI, you see that the OI is created within robot init. So ultimately, the commands won't be created until after robot init is called or during the call of robot init. So the next set of methods that you'll see within the robot class are a series of periodic and init methods. And these methods are related to the different modes that happen during a robot competition. So if you're familiar with FRC and you're familiar with how the rounds typically work, then you know that every single FRC match begins generally with an autonomous mode. And that will last for a certain period of time. And then after the autonomous mode completes, it'll be followed by a teleoperated mode. And then after the teleoperated mode is complete, then generally the robots are disabled. And so the different methods here, like disabled init, disabled periodic, autonomous init, autonomous periodic, teleop init, and teleop periodic, and so on, are corresponding to those different modes during the FRC match. And the way that these methods work is that the init methods will be called once and exactly once at the beginning of the mode start. So at the beginning of the autonomous mode, then the autonomous init method will be called exactly once. The kinds of things that you'll see in the autonomous init generally are maybe kicking off a particular command or command group. For instance, as you see here in this example, autonomous init. And then during the and then what you might see in autonomous periodic, generally the only things you'll see here are running the scheduler, or you might also see various logging methods being called here, like logging information to shuffleboard or a smart dashboard during the round to give information to the players during the teleoperated period or autonomous period. One thing that's important to realize about the periodic methods is that they, as the name suggests, are called periodically. And they're called periodically at a regular rate, every 20 milliseconds. So these methods are called fairly fast. And the magic of scheduling all the different commands is what happens in here, but is handled mostly for you through the scheduler object or the scheduler class, which is provided for you by WPILib. So if you are calling scheduler.getInstance.run within your periodic method, then you can do things like rely on the fact that when you press a button and there's a command tied to that button, then that button command is going to be run by the scheduler. It sort of just handles it for you. Some other things you might see in the init methods is not only starting important commands or command groups for that particular mode, but maybe canceling commands that were occurring in the previous mode. Teleop, as I mentioned before, usually occurs after autonomous. So here in this example code, we're canceling the command that was started in autonomous because we don't want that to be running when teleop periodic or when the teleop mode starts. So that's really all I wanted to say about the robot class. I really appreciate you watching this video, and I hope to see you in our next video. Thank you.